Hello, welcome. So let's make a start. So I'm Bryden. I'm a solution architect at SSW. We won't worry too much about the rest of it because we'll cover most of that in the talk anyway. So I'm going to talk about the things I've learned over those 42 years I've been coding. So I'm just going to go through the big three takeaways that I want people to remember. The first one is never underestimate your users, and we'll come to a few examples of what I mean by that later. Always understand the risks of what you're doing and what balance risk with reward. So don't take a huge risk if there's no reward, and so on. Oh, what did you do, Luke? Oh no, understand common patterns is the third one. So Luke was talking to you about a common pattern. We've got clean architecture, we've got vertical slice architecture. It's really valuable to understand all of those, or the common patterns that are used in whatever part of the industry you're working in. Okay, so in the beginning, there were the dinosaurs. And just as they were dying out, and we're talking about 1981 here, so slightly after the dinosaurs. And we're talking about the period from 1981 to 2023. So to give you an idea of what's happened in that time, that was Time magazine in 1981, just as Prince Charles came to be married to Lady Diana. And the finish of the period we're going to talk about is he's finally become king. So that took 42 years from his marriage until he finally became the monarch. And that period, incidentally, covers the entire period of what you would call home computing. And through that time, change has been really rapid, and in some ways, some things haven't really changed. Some of the same constraints exist 40 years later that were there when I started coding. So, where does this story start? So, 1981, Sinclair Computers in the UK releases a computer called the ZX81. Now, this is a monster of a machine. It's got 1 kilobyte of RAM. I kid you not. 8 kilobyte ROM on it, which has a tokenized BASIC in it, and a 3.5 megahertz CPU. So this thing screamed. And at that time, that was $75 at launch, which is about $400 worth today. So that was affordable for someone to come and buy a computer. And that was the first computer you could actually say that about. So this one was a quarter of the nearest competitor at the time in price. So suddenly, home computers, particularly in Britain, where this was introduced, exploded in about 1981, early 1982. They sold hundreds and thousands of computers, whereas up till then there'd been thousands, maybe a couple of thousand of any other computers sold at that point. So it was a huge influx into home computing at that time. It had a few trade-offs, like your full screen of text, if you had the screen full, took about 793 bytes. That was a little bit of a problem because after your 793 bytes, and then the basic interpreter needed a little bit of memory for housekeeping, about another 100 bytes, that left you about 120 bytes if you had a full screen of text to actually write your program in. So, how did they solve that? Well, if we look at those tiny little keys on the keyboard, they've got the basic keywords on them. And each one of those, they didn't store the letters DIM. If it was dim, we stored a number, say 79. So every one of those instructions fitted in a byte. And then the variable that it referred to might fit in another byte, so it would actually compacted down a fair bit. The other thing was, for graphics mode, every character on the screen divided into 4. So you can see on the number keys, they've got each of the possibilities of a 2x2 matrix of on and off, because of course it was a black and white machine. So you've got 8 different combinations in there. So each character could be treated as a 2x2 pixel, and you could draw stuff as long as you squinted a bit or your eyesight was pretty bad like mine is now. It was all fine. Well, let's have a look at how the cost sort of compared. And we're talking 1982 here, so the ZX81 was about $75. The VIC-20, which are a lot of people's the other common first computer, was the VIC-20 or the TRS-80 or the System-80. We're all around that $250, $300, $400 mark. So still affordable, but a much bigger investment. And then the other one that got around a bit was the Apple II Plus, and which later became the Apple IIe, at about $1,000. So about $5,000 in today's money. So a very significant investment to own one of those, but a very much more powerful machine as a result. So the other thing that lots of people talk about in the 80s was the fashion. So let's have a look. Here's me at age 6. So just starting to learn how to code BASIC, and beautiful red jumper, as was the custom in those days. Your mothers would hand knit jumpers, and that was a huge social thing. People would go and knit in groups. And you can see I'm clearly a ladies' man at a young age there. I'm not sure if I gave the little girl next to me the flowers or not, but we can all dream. So moving on a bit, we're into 1983. And Sinclair again, they were quite an innovative company. They like to miniaturise things, and rather than doing things in what would be considered the proper way, they would take shortcuts with the hardware or trade-offs where you would get, you would reduce cost enormously at some trade-off. So for instance, for the ZX81 and the Spectrum, you loaded stuff off a cassette tape instead of having a disk drive. But you save, $100 or more on the cost of the machine by doing so. So this is 2 years later. The big improvements in the Spectrum is we've got 48K RAM, so 48 times more RAM in a 2-year period. And we're talking about this roughly the same cost. Still got a tokenized BASIC, and you can see the rainbow on the corner. That's telling you the big improvement. It's colour now. So you've got colours on the screen. And you can see there's a lot more of the basic keywords. They're still using the tokenized BASIC, but they've enhanced the language a bit more, and they're getting towards parity with the full BASIC spec at that stage that was being used in the early CPMs machines. So with this machine, I built simple games and maths challenges. So my father liked to provide sort of rewards for achievement. So he offered me the reward that if I wrote a game for my little sisters to learn maths with, so to learn addition and subtraction, they had to type in the answers to simple problems. If I wrote a game that did that, he'd give me a reward, and then the game, if they did well enough on it, gave them a code that they would go and tell my father, and they got the same reward. So we all thought this was great. This was the perfect thing. And really, I think I'm the one who benefited most out of it. At the time, my father thought my sisters were getting the benefit out of it. They were learning maths, but I was learning coding, and that's kept me going for 40 years. So let's have a look at the comparison in RAM. I mean, it's pretty obvious. The middle column there is the expansion pack you could get for the ZX81 that kind of worked as long as you didn't touch the keys too hard, because all the contacts were a bit finicky and suddenly the RAM would disconnect if you pressed the key too hard. But other than that, having the 16K meant you could do something with the previous computer. And here's one that a lot of the youngsters sort of don't believe. This is a page out of a computer magazine from, well, this is 1986. So this is how you got a lot of the software. You would go and buy the magazine from the local newsagent, and then you'd go home and then you'd type in all these hex digits, and these might go 4 or 5 pages, and you'd hope you got the machine code right, and the game or the piece of software you wanted would run. So this is what the people on the home computers were doing. It was a bit more exciting if we moved on to, and we'll get to that shortly. So this is how fashion's moved on. By 1983, rocking the flannelette shirt, and that becomes a staple of the fashion for the next 10 years or so. And 1984, my father brings home an IBM PC, and it had come out 3 years earlier, but 3 years earlier it was the cost of a small car, so no one really owned them. A couple of big businesses would buy one, but by now it was down to $1,500, so that's about $6,000 or $7,000 now in today's money. It came with 2 360 kilobyte floppies and a 5 megabytes hard disk drive. So you were able to do heaps with this. Now, take a look at the comparison here. So we're really not changing cost very much, but RAM is suddenly going up. And this law sort of continues to today, because that's kilobytes. We're in gigabytes now, so we're talking millions of times bigger than this. And 1984. This is my favourite photo out of the fashion photos I've got for tonight, because I'm 30 years ahead of Steve Jobs there. So I'm pretty proud of that. And I've got the black skivvy, but I noticed I was rocking the Steve Jobs haircut as well, which I couldn't believe. 30 years before Steve. And 1984, that was a big year for Apple. That was the year they launched the Macintosh, which they still use that name today. So it had a great name, but the big thing with the Macintosh was the cost. It cost $4,000, so that's almost coming on for $20,000 in today's money for a computer. And that's why it wasn't really, the first Macintosh wasn't a great success. It was only once they refined it and hardware costs started dropping a bit that it became successful. So it was ahead of its time, whereas that's what Steve Jobs learned around this time, I think, was wait until the technology's caught up and be the first mover once you can provide it at a cost that your people are prepared to pay. Don't be the early adopter. And through the 2000s, it was Microsoft being the early adopter with phone and all sorts of other things. They would do it, and then about a year or two later, Apple would come in with, say, the iPhone, the iPad, the iPod. They were all about 1 to 2 years later than the competition, but suddenly the cost had dropped where they could up the features extraordinarily and have what turned out to be the killer product. So if we compare the cost of these computers in today's money, you can see there's a bunch of computers under $4,000, and then you've got the Mac. But there was sort of 2 tiers. There was the home computers, which were the ZX81, the VIC-20, the Spectrum, the Commodore 64, and then a bit later the Amiga and the Atari ST. They were all the sort of home computers that people played games on at home and did a little bit of stuff. And then you had the Apple II Plus and the IBM PC that were building that sort of business computer. So in the period just after this, we start seeing a few trends. So 1984 to 1986, GW Basic becomes the first sort of version of Quick Basic. The big one in here, the big innovation, was Lotus launched 123, which was their first spreadsheet. and this was a huge seller, and it revolutionised a whole bunch of industries, particularly accounting, because suddenly they could do their accounting in an easy, tabular fashion, which before that you were doing it all largely on paper, maybe with a calculator, but calculators were pretty primitive too. So this launched in 1984. I'm about age 10, and my dad's a road research scientist, and he's got 40 years of data that no one's been able to number crunch because there just hasn't been, you had to do it by hand. So he goes, oh, I've got some child labour here, and I'm set to work on doing analysis of all this data that's been accumulated for 40 years. So through that, I learned to identify the patterns in the data, and that in particular is a skill that I reckon everyone should learn, is enough statistics to identify patterns. And what are you going to use that for? You're going to use that for debugging, particularly performance, and understanding things like I might have an HTTP web API. Very commonly, say 95% of my requests come back in 100 milliseconds. The rest, they might take minutes. So it's that 95th percentile or 99th percentile is a really useful piece of statistics to know about and know how to collect it and interpret it. So I learned all of that through there. Another thing I saw was the Hewlett-Packard plotters, which is very like a 3D printer today. It's basically a couple of arms, and it used to have a pen on it. Because of course the dot matrix printers of the day were basically unreadable. So you couldn't read anything. So this was how you would make scientific publications. You draw all the graphs on these plotters, and they made beautiful graphs. So here's my first big rule, is know basic statistics. Don't go into all that high-level statistics. For computing, you just need to understand some basics, but they are immensely useful. So we're now moving on a little bit. We're into 1986, and there's another one of the high fashion jumpers. They're starting to change in colours. There's a few more colours available in the wool as dyes have improved, so things are getting better. And 1987 to 1990, one of the big trends was that Pascal became an enormously popular teaching language and sort of supplanted BASIC to a fair degree in most of the teaching institutions. So this Turbo Pascal then came on and became Ball and Delphi. And one thing a lot of people don't know is that what they built for Ball and Delphi later became all of the memory management in .NET. And around 1999-2000, Borland was about to go bankrupt, and Microsoft was going to end up as basically the only compiler developer in the Windows or MS-DOS Windows space. And they realised that without competition, they were at antitrust problems. So they made an investment into Borland to prop them up. And really the only thing Borland had to give up was 2 engineers for 2 years at a cost of $100 million. But those 2 engineers basically built the garbage collection and the memory management for .NET, and that was the thing that they were really struggling with, was how to do that memory management, because these 2 guys were spectacularly smart. So I remember one of their names was Danny Thorpe. I can't remember who the second engineer was at that stage. The other thing that Borland had going for it was they had lots of patents in really inventive things, and the big one was event handlers. And because they patented that, that meant that all of the other languages and toolkits around had to build things like delegates in C#, which are really, if you look at it, a pretty clunky way of implementing an event handler. And that was because Borland had actually patented that. And you see that quite a lot in computers, that a lot of things are done in the more popular toolkits and other things, because someone's already patented it in another one, and they have to provide the same functionality in a much less simple way. And in 1988 fashion, well, there's my sister looking like Molly Ringwald out of Fast Times at Ridgemont High, I think it was, which was about the same era. So that really was the fashion. And yeah, I'm up to the 2 flannelette shirts at once by that stage. So fashion is moving. And fashion in computers is moving too. 1987, we have IDEs. So I think Quick Basic introduced an IDE in about the same year, Turbo Pascal, and I think they were the only 2 IDEs at that stage. And, you know, for the day, they were pretty schmick. And the thing with these was, you see those top and bottom bars, if you were a coder, those bars would burn in on your monitor, and you would always have file, edit, run and compile and options sitting on your monitor even when you weren't running your IDE, because that was one of the problems with early monitors, was they burnt in. So, and this is my mother's favourite jumper she ever made. I think it's possibly the worst with those interference patterns on it, but it's moving along. And about this time, I got my first job. And that first job actually turned out, I got that based off having some programming skills and using Turbo Pascal for Windows at the time, and having done all that data analysis as a sort of child labour. I got a job writing some software to design road surfaces. So I did this over the Christmas holidays at school, and scarily, pretty much that software is still in use today. It's had a few updates, and this phone app is only 2 years old. Up until then, it was basically an early Delphi app, untouched for close to 30 years. And because it was a relatively niche area, and really the technology behind it didn't really change, like road surfacings haven't changed dramatically in 30 years, they were just able to keep updating it a bit so that it ran on the new operating systems, and that was about all that ever happened. So it's had a new name in the last 2 years. It used to be called CMX up until 2 years ago. And that was only like 4 months worth of coding, and it lasted 30 years. I wish all my software was like that. But the lesson I learnt there was I got an accidental opportunity, and that got me into being able to write commercial software. And that was before I'd finished school. I've written a piece of commercial software, and it's been kind of successful. Like if they'd employed a normal person to do it, the amount that I had to pay them, they'd never been able to keep it going. But because they employed me, it was cost effective to keep it going. And the jumpers are getting worse, as you can see, over the years. And now we move on to, I'm at university, and most of that period, because I already knew Pascal, and at this stage, the number of students in all of these courses, in computer science courses, was sort of doubling every year. So they needed twice as many tutors every year as they needed the previous year. So I go in, I do okay in the first semester because I didn't have to learn anything. I'd already learnt that over the previous 10 years and did very well in the exams. And they, oh, you can become a tutor for us. You'll be great, you know everything. So I spent roughly 5 years going through university, but keeping up quite nicely with everything because I had. And the key thing here was I learnt how to simplify concepts and explain it to people who perhaps would otherwise struggle. So those skills I've used for every year since, explaining to people like product owners, the testers that I work with, and key stakeholders at companies that I've worked for or other organisations. And it also helped with mentoring and teamwork. So it's been, those 5 years tutoring were so valuable. And the key thing you learn in doing all of that teaching people is how to tailor communication to an audience. And it's super important to learn that, particularly in our industry, because we have a very strong tendency to talk in developer speak. And if we're talking to, say, the person who's asking us to build the software, their eyes will just glaze over. So remember to tailor anything you communicate to your audience. And in that period, I got to work on a super modern PC. So that was from 1947, that computer. And we restored that, and it ended up in it's now in ScienceWorks in Melbourne. That's the world's oldest still operable computer. We did actually turn it on for about 5 minutes at a time. And the key problem it had was that the valves would blow after about 5 minutes, because valves aren't very reliable. And the problem with that was it only ran at 1,000 hertz. So you only got about 5,000 clock cycles before a valve blew and the computer stopped and you had to start again. So I helped build the restored card reader for that. And that taught me about understanding the underlying architecture, because you really need to understand the architecture of what you are building on, like the physical architecture of what you're building on, and then you can understand some of the problems you'll hit. Like if you understand how much memory your computer has, you'll understand why loading in exactly that amount of data in, suddenly things are going to start happening because you've run out of memory, so it's paging. But if you don't understand the physical architecture, you'll have no idea that that's going on. So make sure you understand that underlying architecture. And you can see fashion's moved on. Young men are now long-haired louts. So 1999, I go and work in a small startup. So there's just 2 of us. And we're building payroll time clocks, point of sale systems, and telesales systems. So what did I learn here? Well, the payroll time clocks, one of the things was that because we had to keep the cost low, we were using like digital watch, your wristwatch, crystals. And really, they're not very accurate. They lose time far too much. And we went back to the people we were buying the parts from and said, look, how can we improve the accuracy? And they went, oh, well, you can spend, about $2,000 on a crystal. And that's a much more accurate crystal. So that'll keep the time much better. Really? $2,000? We're selling this thing for $2,500. That's all of our money gone just to make the clock accurate. And then we went, well, what's the requirement? We need something that ticks regularly. And we went, what about the power supply? So we went and talked to the Electricity Corporation, and it turned out that they guarantee exactly 50 hertz on the power supply. And if they lose cycles through the day, they'll actually add them back in so that you've got exactly 50 hertz, because that's how all the hospital clocks worked. And they were mechanical. They just read the AC, and that was one tick, 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 tick. That's how hospital clocks worked. So if you lost a few cycles, you had to put them back, otherwise all the hospital clocks wouldn't work anymore. So we just used that and saved ourselves $2,000 per unit. So what did I learn there? Gather the requirements. The requirements were keep the time right. Don't let someone come to you with their already made solution. Go back to the requirements and then have a think about their solution and go, yeah, maybe it's the right one, maybe it's not. And there was a second huge lesson I learned working for this startup. So at that time, we were building point of sale systems, and they looked like this. And there was a full desktop PC under the counter. So one morning, because it's a startup, I'm frontline support, as well as, you know, sales and engineering. But on this morning, I was frontline support. So we were selling to pharmacies, and the pharmacy assistant rings me really stressed, going, I can't make the cash register turn on. I can't make it turn on. So I sort of, okay, I'll go through the motions. Okay, is there a light on the screen on the desk? And she goes, yeah, that's good. Is there lights on the printer there? Yeah. Can you see the red light from the scanner? Yes. Okay, is there a light on the computer under the desk? And she goes, no. And I go, okay. Oh, yeah, they're pretty unreliable, those LEDs. They tend to blow. All right, stick your head under the desk, and can you hear the fan running? She rustles about and comes back up. Yeah, I can hear that. Oh, damn, I've got no idea what's wrong then. All right, I'm going to have to get in the car and get ready and get up early and go. So I'm doing this, and it's about half an hour later, and I get another phone call, and not another support call, and it's the pharmacist. And he says, how did you not sort out that support issue? I said, what? And he got me to run through the steps I'd gone through. I say, asked her to put her head under the desk and see if the fan's on. Oh, and he collapses in hysterics. And I'm, what have I done? And he comes back on eventually and says, well, what she'd done was, it's really hot in the pharmacy today. She'd unplugged the desktop underneath and plugged in her fan so she didn't get too hot. And I'm, yeah, so the lesson there is never underestimate what your users will do. Be very, very clear in your communication. And 1999, where floral shirts are coming in and we're slowly moving along. So in 2000, I finally gave up on being at a startup. The ridiculously long hours were too much, and I moved to a company called Quest Software, which made database performance management software and a few other things. And I spent 20 years at Quest, and while many the people I worked with think I learnt an awful lot there, really what I learnt there was I didn't learn any new skills. I refined all of those skills and maybe learned a few soft skills, but probably they were all kind of there by then as well. But it was the refinement that finally happened. So it was a pretty raw product that came into Quest in around 2000. And 20 years later, I'd like to think I came out a bit more rounded and more friendly. And through that, the key one that we kept coming back to was what Luke was trying to hammer through to you, was learn some common patterns. And he's talking about software composition architecture there, but we were looking at how people use databases, the patterns of that, what the patterns of usage were and all of that, but it's all the patterns. So that's me moving along a bit. So this is what the software looked like. This was dark mode 20 years too early as well. So one thing we did was did an awful lot of the research and aggregated a lot from others about whether dark and light was a good idea. Turned out this wasn't actually a great idea, but it was selling so well we couldn't really stop because everyone loved looking at it. It was just very hard to read for a long time. Thankfully, that this software you don't want to look at for a long time, because if you're looking at this, something's gone wrong. So you want to look at this as little as possible. So what we did know there was that the visual impact of that software was the strength. So we understood where our strengths lay and where our weaknesses lay. Now, I'm going to talk about one of our competitors through that period. And this one taught me another lesson, but thankfully I didn't have to learn it the hard way. So SolarWinds sell database performance management software and all sorts of other system tools. And like us, they had an automatic update system. And like us, they had a very easy to remember password for uploading the files onto that software update system in their test environment. They were very similar in that they were the company name and a few consecutive digits starting at 1 after that. And at this stage, I'd moved up to being responsible for quite a few teams. I kept saying to the teams, we've got to think like anyone trying to attack our software has the source code. So we've got to be very careful with things like secrets. So we were rolling the secrets on our update server in production. It turned out SolarWinds weren't. And someone replaced all of the automated updates for their software, which was then downloaded by 18,000 of their customers. Most of these customers were large federal government departments across the world, Microsoft, Apple, all of those sort of companies. And this software, because it was monitoring their critical business systems, it had administrative access to those business systems to get that critical performance information. So SolarWinds had about 30,000 customers. Similar to Quest, we might have had a few more, they might have had a few more. Of their 30,000, 18,000 were breached by that simple mistake of not rolling passwords. And in the US, that changed the way governments looked at security. But for a few other things that had gone on that had made me think, let's be careful with passwords. Security is actually a big thing. That could have been me that was being dragged in front of the US Congress, because the developers who made those decisions were dragged in front of US Congress and had to testify as to why that was like that. So this was only 2 or 3 years ago they were dragged in front of Congress during COVID. And having to explain to Congress, I was thinking, I'm glad I understood the risks before that. So think about what the risks are, because like a simple decision like that, if it's the wrong system and the wrong thing you do, you could end up probably not quite that big a problem, but the capacity for certain systems to explode is very high. Okay, so we're getting close to the end here. So let's have a look at how RAM grew across that entire period. And you'll notice this is a logarithmic scale. So it wasn't just growing, like this. So we've grown from 1 kilobyte in 1981 when I started to 10 gigabytes is now or 16 gig is pretty much standard. So 16 million times bigger. So RAM's grown 16 million times in 42 years. And we can expect it's going to grow a bit more. CPU speed has grown by well over 1,000 times, but we've also multiplied the number of cores up until basically about 2000. They were all single core machines. So when you see this clock speed, you need to multiply that by the number of cores. So now we're up to about 10 cores. So that's also multiplied by 10 to 100,000 times. Okay, so let's summarise what we've seen through this. I've got about 8 or 10 lessons here. The first 3 are the 3 I reckon that have benefited me most. The first one was never underestimate my users. Ooh, almost tied my tongue there. The second was understand the risks, and particularly in testing. This is the key thing in testing. You're not testing to find bugs. You're testing to reduce the risk that your software fails. And that is the area where I think a lot of people don't understand the risks and the rewards. So understand what the risks of your software failing are and test to those. Understand those common patterns. This is a .NET user group, so understand the software composition architectures, like Luke presented, and you'll see other ones in other talks. Gather requirements. Don't let people come to you with solutions, particularly non-technical people. Get them to bring you the requirements and then build a solution together. Understand the architectures you're building on. So understand the physical architecture, understand the software architecture. You don't need to understand it in great detail, but just enough to know where, you know, the key pain points are going to be. Tailor your communication to your audience. So don't talk in code to your product owner. Don't talk in business speak to your developers. So if you've gone and talked to the business and you've managed to struggle through understanding it, what they were telling you, try and talk to the developers in development language, so in ways they'll understand. Don't just repeat what you were told, because then they've got to do the same translation. Learn some simple statistics. They'll come in useful in so many places throughout the software world. And the one I like is understand your strengths. Play to them and work on your weaknesses, but also when you're building teams, understand all of their strengths and try and balance them. So if you've got one person who's really good at something and one person who's really good at something else, but they're both can't do the other things, put them together. Build teams that have a balance of skills so that they can solve any type of problem, and then seize any accidental opportunity. All right. And finally, some evidence that fashion sense isn't hereditary. Okay, any questions or observations?
I remember coding in Turbo Pascal at school as well, going through all that stuff. We had a Macintosh Plus at home back in the 80s. And
wow.
yeah,
Oh.
we were revolutionary.
Yeah, I think for me ZX81 wasn't that popular at the days, so, but we were completely sold on Spectrum Plus.
Yeah, and the Spectrum lasted about 10 years as a computer because it was so cheap.
You got to talk about the Sinclair problem.
Oh, why he ended up bankrupt? The tricycle. So he built
no,
an...
the other half of it was he pre-announced the computer a year, 6 months. He's like, here's our new computer. We're going to have an amazing one in 6 months.
Oh, he did do that, but the one that killed him was he built an electric tricycle.
He went up on stage, showed off a new product, and then goes, don't buy this one, we've got a better one coming. And then 6 months turned into 18 months because there was development hell. That's what bankrupted. The bike was the second round, but yeah.
Yes.
More of a comment than a question, but I had a Commodore 64 when I was a kid, and that's what got me into basic programming. And I had the magazines where you type in the basic, but I didn't realise you had, before that, there was magazines with hex.
Yeah. Oh.
Like, that must have been next to impossible to get right.
Oh, yeah. It was a celebration when you got one of those to run.
The basic was hard enough, right? Copying it out of a book.
Yeah, and if you the worst one was if you finally got it typed in right, and you would say, then you would issue the command save and save it to the tape. Quite a few times I got so excited I finished typing it in and I've clicked run, and you can't break out of them once they've gone into assembly. So I've lost all my typing after I've played normally they were games at that age, and I was stuck. I could play my game. I didn't want to turn the computer off because as soon as I did, that was the end of my game. And I got to type it in for 4 days again.
You're off camera.
Oh, sorry.
Yeah, I had a friend who had like 4 Amigas, one for every one of their sons. And that was
Wow. So what's that? That's about 1989, the Amiga, isn't it? Or 80?
this would have been about 92, but yeah.
Yeah, so they were very popular because they were another company that were very innovative in how they built the hardware.
16K graphics when everyone else was still barely on 16. Their 16
still used as MIDI controllers for music.
Yeah.
today.
Mm.
They had him interrupt and SCSI was their kind of big thing behind the scenes, yeah.
I was going to say, like, my first computer was also a ZX81, although I didn't really use it much. But my dad bought a ZX Spectrum when I was about 7, and I got into coding at that point as well. But I don't think I would have got into coding if I hadn't gotten a nice book. You know, you remember the spiral-bound book that you got with the Spectrum? But anyway.
Ooh, yeah, yeah.
This was kind of like a central part of having a computer, was making stuff, you know. Nowadays you buy a laptop or something like that, and there's nothing that sort of tells you, you know, you can do things with this thing apart from run Excel, you know. So, I suppose you can sort of code in Excel, but...
That's why Raspberry Pi became a thing, right? Like that was the whole vision, that give an affordable computer to kids that they can then start to get hands-on with and make things with, right?
Yeah. I just want to make the observation that it's not like a mainstream thing now with computers. I suppose computers weren't so mainstream back then, but like the whole idea of computers was creativity and stuff like that. And I just wish there was more of that sort of emphasis nowadays.
Sam.
Say similar idea, because my first computer was obviously much more powerful than one that you were brought up with. And in that same respect, I was never given the opportunity by circumstance to have that kind of heavy restriction that also leads to a lot of creativity and fun. So how would you try and get a kid or person or someone trying to get started with that same sort of creative cage? Because right now you can obviously buy a very powerful computer and have all the power in the world, but nothing, none of the opportunities there.
A very good question, and one I'm wrestling with that one, who's now 15, and he wants to learn, but the problem now is that, you know, the sort of event horizon has gone out, and there's so much to learn that he's bouncing around between this and that and this and that and this and that.
Today we've got different levels of distractions, right, compared to back in the 80s when we might have been playing with it. So I've got an 8-year-old boy and an 11-year-old boy, and the 11-year-old loves playing with like Scratch and stuff like that. And so now the trick to getting them into coding is getting them in a way that's really engaging in a fun way. And then, so for my 11-year-old, he got involved in it, just doing some sort of basic stuff. And then after doing some basic stuff, he's like, oh, if I start using these if statements and start doing this other stuff, I can start making them do all these other things. And so it was getting the initial engagement in a way that then allowed him to expand on it. Whereas, like, you couldn't put a kid down and give them a book that they flip through and they've got lines and lines of, you know, assembly code that they're typing into something. Like, it just wouldn't work today. So the landscape is different. The way kids are interacting with the world is different. So, yeah.
I think, just to comment on that, I think I started programming at university, and we were doing things in mechanical engineering where we had to write variables out to disk while we're doing calculations because there wasn't enough RAM to hold all the variables. So I think it's the best thing about coding in the way I've done it ever since is that can you write code with less code and less RAM and less CPU? If you can, then you should try and do that because you were conserving resources. And nowadays there's so much RAM and so much CPU, you don't have to think about resource use at all. But if every time you write a function or something and you say, can I do this with less code or less RAM, that's a good way to, that's a good policy to code.
Challenge, yeah.
Yeah, that kind of also reminds me of university. Even though we had a lot of RAM, we always, when we're doing assembly, we were like, we can run A, the fastest codes, and B, the smallest code. So there's like two categories, and usually we could only do this with assembler.
Which is interesting because when you get into working in teams in the real world, and you've got someone in your team that's trying to write this ultra tight, short, quick, fast code, it's not maintainable for anyone else outside of that, right? And so that is a fun challenge to try to do, and you feel really smart for doing it, but it doesn't apply to the real world, which is, you know, I always find this very interesting. Or it depends on the context within which you're trying to build. If you're trying to build like high frequency trading, then of course you want to be doing that. If you're trying to build some corporate crud system that in a big enterprise environment, then like if you're writing stuff that's going ultra fast that no one else can step in and maintain, then it's not the right thing, right?
Around like teaching kids, like I was trying forever to teach my kids, and they just weren't grasping it. Recently, I've started teaching them Windows forms, and like they're picking it up so fast because there's a visual element to that. So because they can interact with their app visually, like it's like, oh, the property and it's like background color equals red. I can see that happen. But if you try to teach them web and everything there's just so many layers that they're actually like trying to make you understand stuff. Like even if you just go like basic HTML, there's still stuff they have to understand. That their like learning process just takes so much longer.
I think the big thing there is WYSIWYG editors versus text editors, right? I was going to say, are you going to progress them to Silverlight next? Sorry.
Yeah. Out of a Visual Basic.net book. Yeah. It was drag and drop, and I was a picture editor. And then I got bored out of the book, and then that was enough to get me onto the start Googling like, oh yeah, I can view a picture now. How do I interact with files? How do I?
Like, and I even thought of going the WPF route, but then you've got XAML. That's just like an extra layer of complexity that they don't need to know when they're trying to learn how to do simple things.
Just go straight to Blazor.
Well, if Dreamweaver, was that the name of the Adobe?
Whoa.
That was still a thing you could have them doing web as well.
That would be amazing. My first web apps I built like that because I came from Windows Forms, and then web was confusing because there's this layouts. So I just did position absolute for everything, and I designed WinForms in web. It was amazing until the screen got bigger.
But, I mean, even though I personally hate the language, it might be worthwhile going the Visual Basic route with the Windows Forms for teaching kids that stuff, because curly braces are a little bit weird.
Excellent. Okay, well, we'll wrap up there. So once again, thank you for everyone for coming to the November .NET user group. I got it right this time. Just another reminder that the D2D Brisbane is still a thing. Oh yeah. So again, sponsors tonight are SSW, who have bought our pizza and our drinks and provided us two very knowledgeable speakers, which we always appreciate. Telstra Purple for supplying us this room. But we do have another sponsor. Every month, JetBrains gives us two product licenses to give away. Normally we offer them to the presenters, but our presenters just about always have JetBrains licenses already. So, as a result, we have them available to give away. Bryden, do you have any?
Ooh, I'm going to ask how many people don't have a JetBrains license and would like one?
I don't.
Wow, we're down. I was going to say that from my one, I'll give it to the youngest person in the room, but they've all got JetBrains licenses. So I'm at a loss to.
Who? I can give one away.
Oh, okay.
You had a bunch of questions for both speakers as well, so I can
Yeah, okay.
Yep. Worthy.
Well, that's on the last one now.
Right. We got one more.
Who didn't have a license?
Well, I have one, but I fit it.
It's just free. It's one JetBrains
Product.
for a year. One JetBrains product for a year.
Ultimate.
JetBrains have a whole range of really good products. So there's obviously Rider, which is a .NET IDE. They've got WebStorm, which allows you to build JavaScript-based things, so like front ends and Node applications and stuff. They've also got Data Group, which is another great one that I use for interacting with databases and querying and all that sort of stuff. They've got one for most languages that you could use. So they are a great suite of products. And obviously, they also do ReSharper. So if you're using Visual Studio, you can use ReSharper with it as well. So this is a license for a single product.
All right.
So
I've got one question. Who really loves Visual Studio and hates Rider? That's not SSW. Drink the Kool-Aid, man. That's good. I'll give everyone the same
text
score.
will rise again.
Who gives you Rider and Visual Studio?
Think of beauty.
It is beautiful.
yeah, it's really good.
Go back.
So Todd. Shh. So just wrapping up. Again, we are on the first Thursday of every month. We're always looking for speakers, always looking for sponsors. So if you've got something you feel like you might want to talk about, we're a fairly welcoming group here. We try to kick out any of the hecklers. So yeah, we don't allow anyone giving any of our speakers any grief. So we're fairly welcoming. You're welcome to speak about a range of different things, preferably tech related. So .NET, Bryden's just spoken about his career and life so far within tech. So it's a whole range of things that you can talk about. So if you've got anything, you can reach us on the meetup group. We're also on BrizDev Slack, if any of you are on that. So reach out to us in a whole bunch of different places. So thank you for coming, and I hope you'll have a good night.